All right, let's get started. I think we're close enough. We're all here to learn about coding for network performance, right? Everybody, this is what you're expecting? So amongst the crowd here, what's the mix? How many of you would describe yourselves as more of a DBA? Okay, a few. So the rest of you would kind of self-describe as coders? Okay, DBAs, take note. That's the enemy. So we're going to talk about some of the different things you can do from a coding perspective to help with client-server performance, and try to explain some things about why it's problematic. Whoops. We're going to talk about why client-server performance is challenging. We'll talk about what network messages are and how they impact your performance. We'll talk about some ways to improve your existing queries. Some of them are painless and easy. Some of them actually require you to do work. So I'm sorry, but you'll have to actually do stuff. And we'll talk a little bit about how to analyze your performance so that you can look at what's going on with your network traffic and make sense out of why it's doing what it's doing. And then we'll have we might have a demo if we have time. And then we'll have a little Q&A and we'll be done. This is like double clicking every time. So first, there are some things that you should know about latency. I stole this slide from Gus, updated it a little bit. But everything you do in your programming and in your computing, performance is very much about the latency between operations and between the things that you do. And as you move down the table here, things take longer and longer and longer. So when your data is on the CPU and it's in the L1 cache and you need to access that data, it's very, very fast. It's half a nanosecond. A nanosecond is a billionth of a second. So it's very, very fast. A nanosecond, though, is also the amount of distance that light covers in about 30 centimeters. So in one nanosecond, light can go about 30 centimeters, or a foot if you use freedom units. Other things that happen, things like a branch mispredict. So processors these days try to do things ahead of time and in parallel, but when they make a mistake, that means that you have a cost for that. So if it guesses wrong about the next instruction, that's going to cost you about 5 milliseconds, give or take. I mean, they're all a little bit different, but in that neighborhood. If you have to go from the L1 cache to the L2 cache, you're still not in main memory. That's even more expensive. That's 7 milliseconds as opposed to only half a millisecond. Nanoseconds. Yeah, oh God, yeah. Nanoseconds, not milliseconds. And then so on and so forth. So when you're talking to main memory instead of in the cache, you're looking at 100 nanoseconds. So that's infinitely longer from a certain perspective than the L1 cache was. Then the thing to notice here that's relevant to this talk is that 3 of the top 4, or the bottom 4, on this chart are network related. These are things that you do over the network. So when you send a ping and a round trip within the same data center, so it's not very far away, that's taking a millisecond. A millisecond is a lot longer than a nanosecond. It's 100,000 times, did I do the math right? It's a lot longer. So it goes nanosecond, microsecond, millisecond. If that data center that you're doing the ping to is not in the same physical building, say it's 100 kilometers away, then you're looking at a 2 millisecond ping time. And you would do that if for the 3 or 4 DBAs that I have, that would be your failover database, your data recovery or disaster recovery database, those kinds of things. You don't want them in the same building. You want them somewhere else. Or if you're doing a trip to the cloud, so you're pinging Google or getting some data from Google, that's going to cost you maybe as much as 30 milliseconds over a wired network. So, probably more. Well, from here, yeah. Although they probably have something local. So, but anyway, so as you start moving your data, your client further away from your data, it takes longer to get that data to the client. And that's a big part of what we need to discuss. Progress, the OpenEdge database, has 2 basic ways you can connect to it. There's the old-fashioned shared memory client. So that's where you have a nice character terminal. You log in, you SSH, or, well, nobody telnets anymore. So you connect directly to the server, you start it up, you do that, and it's very, very, very fast. That's why people still do it, because it's fast. The results when you make a query are in memory already. They don't have to go anywhere. You don't have to put them on a network and send them anywhere. They're right there, so the user can use them immediately. The other option is a client-server connection. So you have sockets and TCP/IP communications going on. You have to request the data. The data has to come back. That all takes time. That's where the network time that we were talking about earlier comes into play. Performance might be described as a lot slower. Now, in spite of that, oh, how bad can it be? So it can be pretty bad. That's a Balrog, by the way, in case you're wondering. It's not the Hindenburg. I thought about that. So how bad can it really be? So I did some benchmarking. Many people have done similar benchmarking over the years. And when you're doing shared memory kinds of access, you might be able to read a couple 100,000, I think this is 270,000 or something like that, records per second in shared memory. The minute you go to a client-server connection, and this is a local host loopback connection, so there's no actual network involved here, you're just invoking the network stack, your performance is 3 times worse. You get 1/3 of the throughput. Now that's a lot better than it used to be. If you tried this 20 years ago, you would have had a 10x impact from that. So it really has improved over the years. Progress is not lying when they say that. That's true. If you go from that loopback to a virtual host on the same server, so you're physically on the same server, but you're in a different VM, so you're still not going over a real network, but you're going through a little bit more of a stack, then it's about 3.5, 4 times slower. If you have a wired connection between 2 machines, but they're in the same data center, so they're close to each other, then it's 4.5, 5 times slower. So you're progressively taking longer and longer. And then if you do Wi-Fi, which in a lot of offices these days, you got people hot desking and swapping in and out, they're not really necessarily wired, then it gets even worse. You have a 23 times impact from going over Wi-Fi versus a wired connection. And your mileage will vary. Your infrastructure will be different than the infrastructure I tested, but you'll be within range here. And then if you really want to have some fun, you could try a cloud connection. So you've got your server in the cloud and you've got your clients scattered all over the place. That's really painful. That's 100 times worse because it's so much farther away. And then, if you really want to have some fun and you're on an airplane on your way over to the PUG, you get yourself an in-flight connection and you try to run your test there. It's 5,000 times worse, and you get a whole 54 records per second. It's pretty bad. Yes, Gus?
Which cloud were you using in the?
That was Amazon. That was that's an AWS instance. And like I said earlier, 30 centimeters per nanosecond. It's not just a good idea, it's the law. If you can ever do better than that, though, please let me know, because we can get rich. Okay, but what I didn't tell you, or maybe I didn't emphasize enough, was that was for a for each statement. So that's going out and doing a for each on a bunch of customers, things like that. So you're grouping large numbers of records together. And that's where Progress has done a lot of work in the last, about 10 years to improve the performance of those queries. Those are called no-lock queries. And when you do a no-lock query, you get a large result set all at once. So you're not getting record in independent messages. You're getting a whole truckload of stuff all at the same time. And that's where some of the speed comes from. However, if you look at your code, how much of it is for each statements versus find statements? Anybody want to comment on that? You got a lot of find statements, don't you? Yes, you do. You have a lot of find statements because it's one of those cool things about the 4GL that's different from SQL. It's one of the reasons we like the 4GL. We can go out and we can just find one record. It's very efficient, it's very clean, it's easy to write, people like to do it. And your applications are full of them. But a find statement makes a request, gets one record back. So if you got a find here and a find there, and find, it kind of adds up. So it's not just about the performance of a for each, or your application is about a lot more than just how a for each performs. It also involves the data access from a find statement. And find statements are even worse than what I told you about for eaches. So when you make that first jump from shared memory to that local loop back, and just going through the stack, it gets 15 times worse. Now, interestingly, the throughput for the find statement is almost the same as the throughput for the for each. That's 260,000 records per second. So we lost hardly anything by going from a for each customer to a find customer, find customer, find customer, find customer approach. That didn't really cost much in terms of the algorithm, as long as we're within shared memory. But when you go to the client-server model, you have a 15x immediate pain point there. Now, you may say, oh gosh, I'm never going to go to client-server because that's really horrible. But remember, you're only getting one record, and you're doing it here and there. So yes, it's 15 times slower, but that individual find was not a 2-second operation. It might have been, 15 milliseconds or something like that. But if you do 100 of them in a row, then it's going to add up. And then when you go out further down the chain here to a virtual arrangement, so you go from the local host to the VM on the same server, it goes from 15 to 100 times worse. So that's a lot more painful than it was when we did it with the for eaches, and that's because there's so many more of them. And then the wired connection is even worse, and the Wi-Fi, and then if you try the cloud thing again, now it's like you're doing satellite, only worse. And no, I didn't try the satellite. It would have come out to about a record every 3 seconds is what it would have been on the satellite. So that just was too painful. I couldn't do that. Oops. So what are OpenEdge network messages? We got to have some understanding of what those messages are in order to talk about them. When Progress is sending data over the network, it marshals the data into something called a message. That's when the client receives the data. It comes in a message. The client will make a request. So it says, give me all the customers, or give me customer number 1, depending on whether we're doing a query, which is for each, or whether we're doing a find. The server will resolve that query. So it does a bunch of work in the background. It figures out what indexes need to be used. It figures out whether the where clause is going to work out and all that kind of stuff. And then it packages it up and sends it back. The client might need to upgrade locks. So if you are updating that record and you originally got it with a share lock, now it has to upgrade it to an exclusive lock. So there might be some more messaging going back and forth. Eventually, the client is going to be done with the data, and it releases the record back to the database. It says, okay, I'm done with it. And that's another message. It has to go back because the database now has to know he's not using it anymore. I can unlock it. I can let other people have access to this record. The message itself may not be delivered in one piece. TCP/IP might break it up into multiple packets. So if you have a message that is larger than the MTU, the minimum is that minimum or maximum transmission unit, then it'll get busted up. And that, by default, that's 1,500 bytes. So if you're sending a 1K message, you're going to get it into one packet, but if you're sending a 4K message, it's going to get broken up into 4 TCP/IP packets that then have to be reassembled. So there's a lot of work that goes on there. That single round trip might not take very long, but lots and lots of round trips will add up really quickly. And we have had some experience with some applications, some customer applications that have hundreds of thousands of messages per second, network packets. And on some older systems, it's not so much a problem today, but on older, slower networks, the number of packets actually turns out to be the limit that you run into rather than the bandwidth, which is, and the network guys never think of that. They're, oh, it's 20% utilized, but they don't look at the number of packets and realize that they're jamming up on that sometimes. Right, so for example, a find no lock is going to, as I keep saying, it's going to make a request, and it's going to get a response. Then your 4GL is going to do something. You're going to be done with the record, and then it's going to send back and say, okay, I'm done. So that's 3 messages for a find statement, a no-lock find statement. Now, if you have locks and you upgrade those locks and you update the data, then there may be even more messages. Also, if you're doing something, I talked about this last year, if you're doing something with the client statement cache, so you're tracing your access to the database and the what's going on in your code and where you've been using things, then there are additional messages that get generated. So you can see 7 messages per find sometimes under certain circumstances. Your for each no lock, and no lock is very important here, will fetch the first record. This is by default in 11.7. And then after that first record is sent, as many records as can be fit into the message will be done. So you'll get, if you say for each customer, that first customer gets sent immediately, and then a unit of however many customers you can fit into a message will be sent. So you'll always have at least 2 there. But there are some parameters that were introduced relatively recently that help you control that. So one of the parameters is the message size, MM. By default, in OpenEdge 11, the message size is 1K. The new default in OpenEdge 12 is 8K. So it's become a much larger message size. Then there are these 3 prefetch parameters. Prefetch delay basically says what I just told you about one record being sent immediately. It won't do that. It will wait and put them together. Now, they used to send the one message immediately because 30 years ago, networks were a lot slower, and the client wanted to see that first record first. So it made sense then, but networks have actually improved. So you can eliminate a message by enabling prefetch delay. Then there are 2 others, prefetch factor and prefetch numrex. Factor is how full should I try to make the messages. There's really no reason for that value to be anything other than 100%. I haven't heard of a reason why you would ever want the message to deliberately not be full. So 100% makes sense. The default in OpenEdge 11 is 0, which basically means don't worry about it. The default in OpenEdge 12 is 100%. And that's typical. Progress does a lot of those sorts of things to, when they introduce something new, to not disturb the behavior by magically making a new parameter do something different. So when something like prefetch factor comes along, it'll mimic the old behavior, but allow you to override it. But then when a later release comes along and they have some best practices and a little bit of experience under their belt, then it may change. Prefetch numrex is the number of messages to try to pack into a message. The default for anything older than OpenEdge 12 is 16. So if you do for each customer, you're going to get units of 16 of them. In OpenEdge 12, the default has been increased to a power of 2, 64, We like powers of 2. So what this does is it means that when you're doing a for each, when you're doing those queries, you get a much larger package of data in the return. You're making one request, and you're getting big chunks of stuff coming back to you. And that streaming of the data is much faster than having it come to you one bit at a time. However, this only works if it's a no-lock query. So if you leave off the no-lock and you're doing share locks, or if you're deliberately doing an exclusive lock, it's not going to benefit from this. It's going to act just like a bunch of find statements. It will be very slow. And people do occasionally forget to put the no-lock there, and then they have bad performance. And then they might call somebody who does consulting or something, and somebody might look at their code and say, why is this a share lock? It's really embarrassing. You don't want to have that happen. Okay. So another variety of for each is with a join and sorting. Now these are no-lock queries, so these qualify, but they are joined. So we're getting the orders of the customer, which works pretty well. But when you put that by ship date, that kind of messes things up. And it results in an awful lot of round trips going on because the sort order breaks the ability to package things up together. So rather than do that with a join, the recommendation until recently was to do it as nested for eaches, because then it doesn't get broken up. You would need to figure out how you're going to do the sorting there, but it should resolve it, because your customer you want to come in the right order, and then the ship date would be different. And then another alternative approach here is to build a temp table, or to put this stuff together in temp tables, do your sorting in the temp tables. That's much more efficient than having the database do it the hard way, or it can be anyway. Now, I said this is bad. That was in OpenEdge 11. In OpenEdge 12, we have had some improvements made. So Progress rolled out this feature called server-side joins, which resolves that problem and will make those sorts of queries much faster than they used to be. And you get that for free. You didn't have to do any work at all, which is nice. Patrice, are you in here? Is Patrice in here? Patrice has some interesting information about that. He was talking about it in a workshop this morning for anybody who was in there. Have you had your session yet, or is it still coming? Okay. I think he already did it. So then there's the question of your legacy code and your existing queries. So now that you understand a little bit about what drives poor performance in a query, what are you going to do about it? How can you fix the code that you already have, or not necessarily fix, but improve the code that you already have, make it run a little bit faster? That's what we're going to talk about now. So as I already mentioned, you have the prefetch parameters, and the defaults have changed from 11 to 12. If you're still on 10 or 9 or something like that, you don't have these available, so you're just out of luck. And the recommendations, while Progress has increased the defaults, they probably have not increased them enough. So where Progress has increased the default here from 1K to 8K, I would go to 16 personally. That's what I use, is 16384. Once again, a power of 2, because I like powers of 2. The maximum is 32,000, so you can't go any higher, and unfortunately that is not a power of 2. Prefetch factor 100, that's a reasonable default. That's what you should use. If you think you have a reason to use some number other than 100, I'd really like to talk about that. I'd like to understand the use case there. Numrex, so the default is 64 in OpenEdge 12, but I think that is way too low. If you have a large message, so you've got a 16K message, 5,000 is perfectly fine as a target. Remember, it's not requiring you to put 5,000 records in there. It's just limiting you to 5,000. So if you have small records, or if you have records where you're not fetching all of the fields, you can pack an awful lot of data into a 16K message. So 5,000, make it 10,000. It's not going to hurt anything. But what it will do is if you do have a case where you have smaller records, it'll allow you to transfer a lot of data all at once. There is also prefetch priority, which is, it's kind of like LRU skips for messaging. Instead of checking to see if there's been a message from the client every record, it allows you to skip and only check every 10 records or every 100 records or something like that. It is beneficial. But I usually go with something modest like 10. I don't set it to 5,000 or something like that. Yes?
Why is it beneficial?
Because you're not checking for something that's not going to happen.
But you're running a query, right?
Yes, but it's the database. Well, okay, yeah. It's not particular.
Working, not asking if you have anything to say.
Yes, and it's not like the 4GL is multi-threaded. So, okay. Yeah, I haven't thought too much about that, but it is a little bit beneficial, which I don't know if this shows or not. So I did some benchmarking on the impact of those various parameters to see which ones actually make a difference. So I tried the various different message sizes, prefetch delay or not prefetch delay, factor of 100, so on and so forth. And if you look at the number of queries received and the total number of messages, there's a clear winner. As soon as you start setting the prefetch numrex to a larger value, you get much better performance. You get some improvements from the others. Yes, Rob? Where did I get these numbers from? I made them up. No. Yes, there is a VST where you can get these numbers, which we will discuss. That will be coming when we get to the analysis part of things. I have a benchmarking framework that produced all of this, which we will also discuss. That's the demo if we have time. If we don't have time, I will still be happy to share the code with anybody who wants it. But basically, it runs the queries, uses the VSTs to keep track of how many messages are going back and forth, and then reports that data along with the timing data. And that's helpful because having the information about how many messages there were going in both directions helps you to improve your code by understanding what the impact of the coding things that you're doing are. But this is just checking parameters. We're not checking any actual coding techniques here. We're just checking the various parameters. So we get this really good result with prefetch numrex 10,000. So, whoops. So then tried that, plugged it back into the matrix to see whether or not combining it with any of the other things had any significant impact, and it brought them all down, or almost all of them down. But still, at the end of the day, the combination of prefetch delay, prefetch factor 100, and prefetch numrex 10,000 was the clear winner. So cool, you can do that. Those are startup parameters. You didn't have to change any code, and you've already made things a lot faster. So that's the free and easy stuff, but now you've got to focus on where should you make code improvements. And when you're making code improvements, it's really important to pick your battles. Now, how many people have seen this slide before? I show it a lot. This is something called Amdahl's law, and it basically says the performance improvement that you're going to get from a coding change is proportional to the amount of time that thing that you're changing gets used. So it doesn't do you a whole lot of good to change a feature that only gets used once a week. What does you a lot of good is to change features that people are using constantly, things that have a big impact. So you got to be able to find those things. Well, how do you go about finding them? Whoops. Yeah. There's a couple of ways to do that. First of all, you can try to observe which tables and indexes in your application are really active. So where is the activity? Is it customer records? Is it orders? Is it the vacation table? I'm using examples from the sports database, obviously. Maybe people are checking on their vacation time on a regular basis, and that's just beating up your system. I don't know. But if you observe what's happening in your system and you know where the high activity tables and indexes are, you have a chance that you can focus on where the queries are that are driving that. That's a kind of a high order 40,000 foot thing you can do. You can use the client statement cache to identify which statements in your code are driving database activity. So I did a talk on this last year. You can get it off of YouTube if you want to check it out. But basically, you can, as your code is running, if a user calls and says something is slow, or you know that something slow is about to run, you enable the client statement cache, you watch what's changing in there, and you see which code gets executed, and you say, oh, that's where it is. You don't have to guess. You don't have to go hunting through the code looking for stuff that that queries the customer record or something like that, because you know exactly what line of code was executing. It's very efficient. Or you could use the profiler. So the 4GL profiler allows you to take a piece of code that you know is going to be slow, execute it with the profiler enabled, and then you'll get information about how long each line of code took to run. And the bits of code that run the slowest are almost always database access statements. It's usually some sort of query that returns a lot of data, and that's where you want to focus your efforts. It's not always database statements. Sometimes you do things that are not databasey, that are slow, but it's usually database stuff. There's a feature that consulting work has, they call it service telemetry, which you can plug into your PAS-OE and your app server code to determine which of those services are taking longer to run. That's a really good way to focus in on something that needs improvement. Or you can do what quite a few people do, which is wait for the users to complain. How many of you, is that your primary way of identifying places to, yeah, okay. I figured there were a few. But, well, that's true. But years ago, time for a war story, I was at a customer site, and we were working on some performance problems, and we were working in a particular area, and we thought it would be helpful to go out to a branch office and see what was happening for real in the field instead of what was happening in the home office where all the executives were, but nobody actually did any real work. So we went out to a branch, and we're wandering around, looking over people's shoulders, watching what they're doing. And this lady goes to a screen, and she does something, and then she gets up and goes to get a cup of coffee. And I'm looking at the screen, and the screen hasn't moved. And I was like, so does this happen every time? And she says, oh, yeah. How long could this take? It might take 40 minutes. And I'm looking at the screen and I say, that should have been nearly instantaneous. There was a missing part of a where clause, and it was going out and it was querying millions and millions and millions of records to return one. So that was an easy fix once we knew it was a problem, but nobody complained about it. I guess she liked being able to take a long coffee break. Some other ways you can do it, or ways that you can focus in on things. So ProTop, yeah, this is a little bit of a pitch, but we monitor all of the table activity, and you can get charts and graphs on which tables are active, how active are they, and you can see which ones are radically more active than others. So we have this faint blue one up here, which I think is SO deposit or something like that, sales order. It's a sales order table. It's getting an awful lot of activity. But what you also see there is that's in the middle of the night. So that's during the batch window, and nobody cares. So zoom in a little bit more, and there's a different table that's very active there, and that one I think is accounts receivable, maybe something like that, and that's during the business day. That's much more important. There are people that are sitting at their desk doing things. These aren't automated processes, so you want to focus on that because you're going to get a return. People are going to say, "Hey, good job," whereas you make the batch job run in 10 minutes instead of 4 hours, nobody's ever going to say anything. So there's also the real-time protop. So if you just want to see what's going on right now and not necessarily want to look at the history of things, you can see the table and the index activity and what the rates are, and it comes with the client statement cache information right there. So if there's something happening right now, you know that line 1913 of whatever that is responsible for 200,000 block accesses per second, which is probably about 100,000 record reads, which are almost certainly these guys right here, coming out of prod exp loc q at the top. So you can go in, you can find that piece of code, and you can look at the where clause, and you say, ooh, wait a minute, that's supposed to have the branch number field in it or something like that. A lot of the times the issue is really obvious once you look at it. Sometimes it's not so obvious, but so that helps you to identify where the problems might be. Once you've identified that, there are some things that you might be able to do to improve it. One of the coding things that you can do is to use a fields list. So if you're in a client server environment, you don't necessarily want to send every bit of the record back to the client. So if you're just generating a list of customer names, you don't need to know their city or their state or the postal code or any of the other information about the customer. You just need the customer name. So add the name and maybe the balance if you're showing that to the fields list, and just those fields will be returned. That means that you can pack way more records into a message, and you'll have far, far fewer messages coming back than if you get the whole record. Or you can say, I want everything except one particular field. So if you have a field like the photo that is a very large field, you can just exclude that one and have everything else if you're only using it rarely. Field lists only work with for each statements. You can't use them with a find statement. On the client side, there is a cache value if you're doing a defined query kind of approach. I would encourage you to increase that. The default is 50, but some tests seem to say that the default is not 50. Some low number is more appropriate. But anyway, if you manually set it to 1,000 and you're doing that kind of coding, then that can help too. And there are equivalents for these things in the dynamic structures as well. I'm showing static structures, but all the dynamic coding has these things as well. Some things that you might find in your code that are hurting you, that you will possibly want to take out, are things like a share lock. So if you have an accidental share lock, that means that you wrote for each customer, : that's a share lock. You didn't say share lock, but by default, it is a share lock. So you need to go and insert the no lock in there and make sure that you have the right kind of query. Otherwise, you're going to have a lot of pain, because instead of getting groups of records back in your messages, you're getting one at a time again. So you're going back to the find kind of a thing. And that can make your query 100 times worse, just because you forgot to say no lock. A couple of months ago, I had that happen at a customer, a big customer, who pushed a change out to their production environment, and things were really, really slow in this one particular service they were kind of dependent on, and they were in a panic. They were worried that something had happened to the server, or we had a misconfiguration or something. I'm looking at it, like, the server's fine. And then we were looking at the real-time display and the code that was coming up to floating up to the top there. And so, well, why don't you look in this program right here? And the head programmer took a look in there, and he's like, oh, he forgot to put the no lock on. So it was a really easy fix as soon as he looked in the right place. Sometimes you have a bad where clause. That's where you're either leaving something out, or maybe you're putting the where clause together in a inappropriate fashion. I think we had an example in the back of the room recently. So you can make some changes to your where clauses to make them much more efficient as well. The whole thing about nesting and joins that we talked about earlier, that's a little bit version dependent, but if you're still on OpenEdge 11, that's something you might want to pay attention to, which is a good question. How many of you are OpenEdge 11? 12? Good. 9? Just checking. So, and break by is another one that may be causing you problems, depending on what you're breaking on and where you're doing it. Can do. Do we have any can do fans? Can do is a security function. It is not a string manipulation function. It doesn't help you, especially not in a query, because if you have a can do in a query, all the records have to come back to the client to be evaluated, because can do executes on the client. It doesn't execute on the server. And that's gonna really cause a lot of problems. So instead of using can do, you should be using lookup. Okay? I know there's a certain application out there that uses can do all over the place. It's a bad idea. Yes?
What's the difference between lookup and can do?
They're both functions, but the difference is can do is executed in the context of the client. It cannot be resolved on the server, whereas lookup can be. They have the same result, except the arguments are flopped.
The result's not the same either, because can do has different escape characters.
Yeah. There are lots of side effects, and if you're using can do because you want wildcards, you need to find a better solution than that. But most of those things are solvable too. There are several ways to solve the can do problem. I'm not here to talk about that. I have another talk about that, and we can cover it later if you want. Oops. Okay. So then this chart was prepared in a manner very similar to the other chart. But instead of checking or testing startup parameter differences, we're testing differences in coding style, ways of approaching a coding problem. So basically they're all getting the same amount of data. So the query is essentially the same, but it's put together differently. So do while true, do while available, find no lock to get the data. Do it with a share lock, do a for each, do a for each no lock with a fields list, et cetera, et cetera, et cetera. And there are some very significant differences in the performance based on how you put together a query that returns the same data. So the time, the best time in this chart is the for each no lock with a fields list. That gives you far and away the best result. And that's because the total messages is so much lower. The total number of messages that you're sending across the network is minimized, and so your time is as well. Although you might notice that the SQL 89 select statement also does quite well. That doesn't make me a fan of SQL 89. But just to be, completely honest, yes, it is quick. Yes?
Why is for each share lock by far the most expensive in terms of messages?
Why is for each share lock what?
Why is it so expensive in terms of messages? It's 1.5 times as much as exclusive lock.
I don't know. I didn't think of that. Not sure why. There might be a lock upgrade happening, but I didn't do an update, so I don't think there should be. Could just be that nobody ever actually does that, and so nobody's paid any attention to improving it. Sounds like a bug. Okay. I'll see about reporting it, see if we can get something done.
So in that for each share lock,
Yeah.
what was the scoping?
Oh, yeah, that could be it. I didn't pay any attention to that. It probably looked a lot like this, but with, yeah, it probably looked a lot like that, but without the nesting, and without the no lock, obviously. So it's scoped to the procedure rather than to the, and the procedure has all the code to do the VST stuff, so there's probably a reference to underbar files somewhere out there. That's might be a bug on my code rather than a progress bug, darn it. Anyway, so this is an example of doing these things with some joins and whether they're nested or not nested to kind of illustrate what I was talking about in that earlier slide in version 11 where you don't have server-side joins. The nested for eaches can be much better than the join. And also, if you build a temp table to solve this problem, then you can go even better. And I'll talk about that right here. So when you're doing joins, particularly if you're doing joins of a small table with a large table, so maybe you're going through your orders and you're joining it with the sales rep, and there's only a couple hundred sales reps in your organization. Now, if you have millions of sales reps, it's probably not going to work. But if you have hundreds or even thousands of sales reps, it may make sense to build a temp table rather than join with the database table. And you do that by creating the temp table like the original table. Make sure you only have one index on it because you don't need the other indexes. And then substitute the temp table in where you previously had the real table, and magically a whole bunch of your traffic back and forth goes away. Kind of cool. Takes a little bit more coding than just changing a parameter, but it's an approach that is easy to take and can quickly solve the problem. Now, you don't necessarily need to do that if you move to OpenEdge 12, because a lot of this gets taken care of by server-side joins. Which isn't to say that the temp table thing is not useful. We're going to have another reason to use it in a little bit. But in OpenEdge 12, the server-side joins really do make a huge difference for queries which can take advantage of them, which is not all of them, but quite a few. So we did a few more, tests that include the server-side joins. And this one right here, we added the sales rep not equal. So we're looking for all the orders that were made by a sales rep who was not Gus. Do you know you were in sales? Which typically, that kind of logic where you're looking for something that is not something is typically very expensive because it's difficult to write and it involves looking at a lot of stuff on the client side, but the server-side join is a real good way of solving that problem. And as you can see, the time here was significantly faster because we were able to take advantage of the server-side join for that. Yeah. So what do you do about find statements though? You know, that's all focused on making your for each statements go faster. But really the find statement is the one that is kind of causing more problems, or might be causing more problems. Well, the traditional answer to how do I take care of find statements is, well, use shared memory. But we're in a world where we can't always use shared memory. We may have corporate IT that is saying, nope, sorry, database server, nothing but database server. You can't have any client connections on the database server, no shared memory. So that means you can't have good old character terminal interfaces running on the server. You can't have classic app server. You might get away with PAS-OE if you put it in a container and do all that fun stuff, but you still have a little bit of a shim there. So you want to keep your clients close to the server. That is to say, you want the ping time to be as small as possible. So think about where your clients are in relation to your server and what you can do to make them closer. Make sure, or try to make them be in the same rack, or maybe even in the same physical host. If it's a virtualized environment, you can have one VM be the database server, and you can have other VMs that are the clients. Just don't over provision it so that you have, if you've got 16 cores, the database server should not be 16 cores. It should be 4 or something like that. And the clients could be 8 or 10 or 12 of the cores. So you're using the whole server, but you're not overusing it. That will work reasonably well. If you are a cloud application in Azure, you want to use something called proximity placement groups. That's Microsoft talk for these servers are very close to each other. If it's AWS, you want to use something called a local zone, which means that the servers are very close to each other. These options do cost money, but you get what you don't pay for, or something like that. Okay. Whoops. Yeah. Okay, so we already mentioned find statements use a lot more. They use a lot more messages than equivalent for eaches. There's the 3 request, response, release part of things. And lots of little things can add up. You remember earlier I said when you pick your battles, you want to pick out the big stuff. Well, that's not always it. Sometimes you're in the sand, and the problem is that you're up to your neck in sand. So now you've got to find a way to address particular finds. So think of it this way. If you're doing 100 million finds, reads of a record, and if you can eliminate those, then if you do that in a local host kind of environment, then over the course of a day, you'll save about an hour. So that might not really be worth it. But if you do this in a virtual environment, you're saving 11 hours. If you do it in a cloud environment, you're saving 556 hours, or almost 70 full-time equivalent employees. Now, you would need a fairly large organization for that to be practical, but 100 million records, it's not really that many. I think that comes to about 100 per second. No, wait a minute, that's not right. What is it? 100 million finds is Rob, you doing the math? Day. Okay, 1,157 records per second. So when you think about that in the terms of your database activity, that's actually not that many. And if you have a database that's supporting 1,000 users, there's a real good chance that you have an opportunity to do something like that. And one of the ways that we identify those opportunities within ProTop is with a metric that we call churn. And it's really common to find an application where you have a relatively small table that is read constantly. These are control tables, they're master tables, things that tend to be read-only. And they churn. So if you have a table which is being read 1,000 times per second, churning 1,000 times per second, that's the ratio between the size of the table and the number of reads, then you have an opportunity to eliminate 100 million reads a day. This opportunity is quite common, like I said. We see customers frequently with these tiny little tables that activity is a third or a half of the database activity, and they're not that hard to find. Now, how many of you think that find first is going to improve performance of a find statement? Excellent. I have repaired everybody's flawed thinking. I've been beating on that for years. It's not faster. It's only faster if the find was not unique. And if the find was not unique, what are you doing? You should be doing a for each. So I don't have to waste time talking about find first. Thank you all very much. When we talk about the high churn tables, there's a magic trick that you can use. And you may have heard about this before too. But frequently, especially if you're looking at a legacy application, you'll have an include file that is in every program that you write, or almost every program that you write. It might even be named common.i. That was a model that Progress released onto the world in version 2 or 3 or something like that. It's been around forever. It was in some sample code and everybody copied it. I'm guilty, I did. And I know lots of other people did too. So if you have a model where you have an include file or some other structure that every program manipulates, and you also have a table, which is kind of small and read-only or read-mostly, then there's a really easy trick that you can use to make all of that go away for everybody. And that is, you define yourself a new global shared temp table, like the other table. Yeah, I did say new global shared. It's true, I did say that. But, you know, I'm all about performance. And you're hiding this in an include file where nobody else ever needs to see it. So you declare that temp table, and now every reference to that table name is going to be replaced with the temp table. You don't even have to change any other code. You don't have to change the name to TT location. You can just use the original name. And then what you do is check to see, are there any records in that temp table? Oh, no? I must be the first one here, and fill it. So you go and you read dbname.tablename. Now you get the real database table, not the temp table, and create it, buffer copy it, and you're done. And this can really, really quickly make it easy to eliminate a great deal of network traffic. Goes away, poof, just like that. Now there can be some complications. Sometimes it's not read-only, it's read-mostly. So if it's read-mostly, then you really need to think about, well, how do I know it's time to reread it? And that could be something simple. For some people, it's as simple as, well, we restart every night and these new records aren't going to be there more often than nightly, so it's okay, we don't worry about it. For other customers, it might be, well, we're going to put a timer in there and every hour we're going to refresh the table or something like that. Or you can get really complicated and you can write some fancy object-oriented code and you can have a caching class and you can have times to live and methods and all kinds of fun stuff like that. That all works too. And as the quote says, there are 2 hard things in computer science. Naming stuff, see, I just use stuff because it's hard to name stuff, and cache invalidation, and off by 1 errors. Anyway, that was a joke. You were all supposed to laugh. Whoops. Okay, we also have a enhancement request on the portal, the ideas portal. Something that you may have noticed if you're looking at your code is that you find something, and then you find something else, and then you find something else, and you have a whole string of find statements occurring. Thank you. And wouldn't it be nice if instead of request, wait for response, request, wait for response, request, wait for response, the 4GL said, hey, this guy wants 5 things. I'm going to ask for 5 things at once, and I'm going to give them all back at the same time. Wouldn't that be great? So head on over to the ideas portal and vote for 1576. And who knows, maybe sometime in OpenEdge 13 we'll have an enhanced find statement. I hope. That would be really cool. Okay, so I promised I was going to talk about the VSTs. So, Rob, here's your answer. There are some VSTs that give you insight into what's going on with your client-server messages. You can get data about them. And the data that you get, one of the key things to remember is when you see received or sent in the field names, that's from the perspective of the server. So the server received the data, or the server received the message, or the server sent the message. It's not from the client perspective, it's from the server perspective. And you can get all of the data that was in the benchmarks that I showed by looking at this. And if you're in a development environment and you're the only user, then really you just need to use server ID equals 2. That will be you. You're the only one. But otherwise, you'll have to go through some fancy contortions to figure out which server you're actually talking to. And the benchmarking code, the framework here, does do that. But for simplicity on the slide, we're going with server equal 2. And in ProTop Real-Time, that shows up here in our server activity panel. And the fields that you're mostly interested in are these red ones: the number of queries received, the records sent per query, the number of bytes, the messages received as opposed to queries. So queries, from the VST perspective, are the for each no lock statements. Messages are, queries are a subset of messages. So you have them double counted there. And then the messages sent and the records sent per message over there. And that stuff is also charted, so you can see what the trends are. So if you're releasing some code and you did something wrong and all of a sudden you have a lot more traffic, then you're going to see some spikes in the charts. Okay, this is the test harness that we're not going to have time for. I'm being signaled by my room monitors to hurry up. So we won't be doing the demo. Wow. Yeah, so we don't have time for the demo. The summary is use large prefetch numrecs. That's critical. It's an easy parameter change. It will give you some improvements for your for each queries for free. You won't have to do any extra work. Use a large message size. So set bigger than the default. Use a fields phrase anywhere where you reasonably can do so. That's got to be the other room. It's obviously got something really cool going on. Use temp tables to cache your data locally. There's a couple of different ways that you can leverage temp tables, but they will help you a lot to, if you think about the flow of your data, to get it to go efficiently. The server-side joins in OpenEdge 12 are another free feature that you can get big benefits from. Taking a look at your code, looking at the small things that can change that is a good thing to do. Ping time is really important. So when you're working with the infrastructure people, you really, really want to make sure that you emphasize the closeness of the clients and the servers. You don't want them deploying clients in one data center and servers in another data center, for instance. That will be disastrous. And simple little mistakes like forgetting to put no lock on a where clause can be disastrous. So there you go. Any questions? Yes, in the back.
You said the number queries was for client, was for each no locks. Is that for the other queries as well?
Okay, I'm sorry, I can't quite hear you.
You said that the for each, the last numbers you get out of the app. So the number queries was for each no lock.
Yeah.
For each deadlock exclusive.
Those will just, so if it's a for each share lock, it'll show up as a message. It won't count as a query. Okay? Anything else? All right, well, thank you very much.